For more than a century, the story of the dinosaurs' extinction has been told in its simplest form. A massive asteroid strikes the Earth, the skies darken, life ends suddenly. This explanation is easy to understand and dramatic to imagine, but it does not reflect the full reality of what happened at the end of the age of dinosaurs. The asteroid impact was catastrophic, but it was not the beginning of the end. It was the final event in a long chain of environmental crises that had already weakened life on Earth. By the time the asteroid struck, dinosaurs were not thriving in a stable world. They were surviving in a planet under constant stress, shaped by forces far greater and longer lasting than a single moment of destruction. To understand why dinosaurs disappeared, we must look not at one event, but at millions of years of change. A world ruled for millions of years. Dinosaurs first appeared over 230 million years ago. They lived through multiple extinction events, dramatic climate shifts, and the slow rearrangement of Earth's continents. They adapted to deserts, forests, polar regions, and coastal plains. Some grew to enormous sizes, while others remained small and agile. Their long dominance is proof of evolutionary success. No fragile species could survive for more than 160 million years. During much of their history, dinosaurs lived in a greenhouse world. Temperatures were warm, sea levels were high, vegetation was abundant. But stability in Earth's climate is never permanent. The Late Cretaceous, a planet under stress. The last chapter of the dinosaur era unfolded during the Late Cretaceous period. This was not a peaceful or balanced time. Sea levels fluctuated dramatically. Large inland seas split continents apart, then slowly receded. These changes fragmented habitats and isolated populations. Regions that once supported vast forests became drier and less productive. Plant diversity declined in many areas, directly affecting herbivorous dinosaurs. Ecosystems became less resilient. Small environmental disruptions now caused larger consequences. Dinosaurs were not disappearing everywhere at once, but their diversity was shrinking. Some groups flourished briefly, while others quietly faded from the fossil record. The world was changing faster than before. The Deccan Traps, Earth's longest disaster. While the asteroid often dominates public imagination, one of the most destructive forces in dinosaur history came from within the planet itself. In present-day India, massive volcanic eruptions known as the Deccan Traps began erupting near the end of the Cretaceous period. These eruptions were among the largest volcanic events in Earth's history. They did not last days or years. They continued for hundreds of thousands of years. Lava flows covered enormous areas. More importantly, vast quantities of gases were released into the atmosphere. Carbon dioxide caused long-term global warming. Sulfur dioxide formed aerosols that blocked sunlight and caused acid rain. The climate swung between extremes. Periods of warming were followed by cooling. Rainfall patterns shifted unpredictably. These changes disrupted ecosystems on a global scale. Collapse of the food chain. Plants were first to suffer. Acid rain damaged forests. Reduced sunlight slowed photosynthesis. Some plant species disappeared entirely. In the oceans, plankton populations declined. Plankton formed the base of marine food webs, and their collapse affected countless species. Herbivorous dinosaurs depended on stable plant ecosystems. As vegetation declined, their populations followed. Carnivorous dinosaurs depended on herbivores. As prey became scarce, predators struggled to survive. Food webs weakened from the bottom up. This process did not happen suddenly. It unfolded over hundreds of thousands of years, slowly eroding the stability of dinosaur ecosystems. Climate change and habitat fragmentation. As volcanic activity continued, climate zones shifted across the planet. Regions that were once warm and humid cooled. Others became hotter and drier. Dinosaurs adapted slowly. Large bodies require time, resources, and stable environments to survive. Migration became increasingly difficult. Rising and falling seas cut off land routes. Continents drifted farther apart. Populations became isolated. Genetic diversity declined. Extinction risk increased. Dinosaurs that once dominated wide territories now existed in shrinking pockets of suitable habitat. The hidden role of disease and stress. Environmental stress weakens immune systems. This is true for animals today, and it was true millions of years ago. As resources declined and populations crowded into smaller areas, disease likely spread more easily. Pathogens thrive in stressed ecosystems. Although disease rarely leaves direct evidence in fossils, its effects can be inferred from population decline patterns. Dinosaurs faced not only hunger and climate stress, but also biological pressure from illness. These invisible threats further weakened already vulnerable species. Competition in a changing world. While dinosaurs struggled, other animals quietly adapted. Early mammals were small, flexible, and efficient. They required less food and reproduced quickly. Birds evolved new flight capabilities and feeding strategies. Reptiles and amphibians adapted to fluctuating temperatures by slowing their metabolism. In stable times, size and dominance are advantages. In unstable times, efficiency and adaptability matter more. Evolution does not reward strength, it rewards survival. As ecosystems collapsed, dinosaurs lost their competitive edge. Decline before the impact. By the final million years of the Cretaceous period, dinosaur diversity was already reduced. Some groups had disappeared entirely. Others existed in fewer numbers and limited regions. This does not mean dinosaurs were doomed regardless of what happened next, but it does mean they were vulnerable. Their ecosystems were fragile. Their populations were stressed. They were surviving, not thriving. The asteroid impact. Approximately 66 million years ago, a massive asteroid struck Earth near what is now the Yucatan Peninsula. The impact was immediate and devastating. Shock waves traveled across the globe. Wildfires ignited over vast areas. Tsunamis reshaped coastlines. Dust and soot filled the atmosphere, blocking sunlight. Global temperatures dropped sharply. Photosynthesis slowed or stopped. Food chains collapsed rapidly. For a world already weakened, this was catastrophic. Why the asteroid was not the beginning? The asteroid did not strike a healthy, stable planet. It struck a world already under extreme environmental stress. Volcanic activity had altered the climate. Ecosystems were fragmented. Food webs were weakened. The impact was not the cause of decline, but the final trigger. Why some life survived? Not all life disappeared. Small mammals survived by burrowing and eating diverse foods. Birds adapted their diets and behaviors. Reptiles slowed their metabolism. Flexibility was key. Dinosaurs, especially the largest species, could not adapt quickly enough to sudden global darkness and cold. Their size, once an advantage, became a fatal limitation. Extinction as a process, not an event. Extinction is rarely a single moment. It is a process. Species decline gradually as environments become increasingly hostile. By the time a dramatic event occurs, survival margins are already thin. The asteroid did not wipe out dinosaurs instantly. It ended a long struggle. The lesson of the dinosaurs. The story of dinosaur extinction is not just about the past. It is a lesson written into Earth's history. Climate change, environmental disruption, and habitat loss have caused mass extinctions before. They will do so again if left unchecked. The dinosaurs were not failures of evolution. They were victims of a planet in rapid transition. Conclusion: the last blow. The asteroid was not the worst thing dinosaurs faced.